So we're going to dive a little bit deeper into this marginal rate of substitution. We kind of covered the basics of it, but we're going to dive a little bit deeper and give it a little bit more of a justification as to why we're looking at this marginal rate of substitution and what is that trade-off. So the marginal rate of substitution of hamburgers for tacos can be equated to the ratio of marginal utilities. So first off, what is this ratio of marginal utilities? Well, that ratio of marginal utilities looks at the marginal utility of burgers to the marginal utility of tacos. It's looking at a ratio here. What is basically the change in utility, the additional utility of the burgers versus the additional utility of these tacos? That marginal utility. And if we remember, that marginal rate of substitution of burgers for tacos is equal to the change in tacos divided by the change in burgers. That rise over run that we talked about in the very last video. So how can we equate these two together? We said up here that we're going to be equating this marginal rate of substitution to the marginal ratio of marginal utilities. So let's look at the mathematical foundation for equating these two. So if we have marginal utility of burgers on top, and that marginal utility of burgers is equal to the change in utility divided by the change in burgers. So if you remember way back when we introduced marginal utility, we said marginal utility was equal to the change in utility, change in total utility, divided by the change in consumption. That's where this formula is coming from. We're equating this all the way back to one of the beginning videos of this chapter. Then for the marginal utility of tacos, we have change in utility divided by change in tacos. So if we plug both of these into this equation right here, what we find, or up into this equation right here, we find that we have the change in utility over change in burgers, because all I did was I took this right here, this equation, plugged it into that portion right there, divided by the change in utility divided by the change in tacos. Now, how do you divide by a fraction? Well, you multiply it by the reciprocal, right? So we're going to take this and basically times it by the reciprocal. We're going to take the change in utility divided by change in burgers times a reciprocal. That reciprocal is just basically taking this fraction and flipping it upside down. So now we have the change in tacos divided by change in utility. We can cancel out both these changes in utility, and lo and behold, guess what we have? We have the change in tacos divided by the change in burgers. So then basically we're saying all of this down here was to justify that, yes, the change in tacos divided by change in burgers does equal this change in, or the marginal utility of burgers divided by the marginal utility of tacos. All this down here was just to simply justify this equation. Well, if we know that that's the equation, if we know that, yes, these two are equal to each other, and we know that because we just proved it, we're going to rearrange this formula that's above. So what we're going to do is we're going to take this marginal utility of tacos and multiply it by both sides, and we're going to multiply change in burgers by both sides. So guess what? We have change in taco times the marginal utility of tacos is equal to the change in the burgers times the marginal utility of the burgers. So why did we do all that? What does all that mean? Well, remember that marginal utility of tacos looks at the additional satisfaction of additional tacos. So we're looking at how does additional tacos, if we say we had more tacos, that the more tacos we have times the satisfaction of those additional tacos would have to equal the cut back in those burgers times the lost satisfaction of those burgers, because we have to stay along that indifference curve. So let's kind of put it more into text right here. A cutback in tacos times the marginal utility from these tacos is going to be equal to the increase in burgers times the marginal utility of these burgers. what we're doing right here is with this equation, we are now justifying the aspect that we can move up and down this indifference curve, or up and down this indifference curve, and we remain at the same level of satisfaction. So we know that a rational person seeks to maximize this utility, and they're going to stay along this indifference curve because that's going to provide them the maximum amount of utility that they can trade off between two goods and still receive the same amount of utility. But as a person moved from M to Q, the person traded 2 tacos for 1 burger. But as they moved from Q to R, they traded just 1 taco for 1 burger. Why all of a sudden is up here 2 tacos worth 1 burger? But down here, all of a sudden that taco becomes more valuable per se. And it's 1 taco for 1 burger. Why is that the case? Well, we start dealing with, very simply the answer is the law of diminishing marginal utility. That as a taco consumption falls, the marginal utility of tacos rise. As the burger consumption rises, the marginal utility of burgers fall. So as we move down this ISO utility curve, as we move down it, we see that the marginal utility of burgers actually falls because we're consuming more burgers. So the value that we place on these burgers is falling because we're consuming more burgers. But by the same token, as we move down this indifference curve, the amount of tacos that we consume falls, which means the marginal utility of those tacos rise. So we actually place more value on these tacos and less on the burgers. So as the marginal rate of substitution falls as you move down the indifference curve, or the marginal rate of substitution actually falls as you move down the indifference curve, you're actually willing to trade less tacos for more hamburgers, or for 1 more hamburger as you move down this indifference curve. So we can see that here. As we move down that indifference curve, here we traded 2 tacos for 1 hamburger. Here we only trade 1 taco for 1 hamburger. Why? Because the marginal utility obtained by off of those burgers is falling, where the marginal utility off of those tacos is rising. So as we move down, that marginal rate of substitution falls as you move down the indifference curve. So this is why this particular formula comes in pretty handy. Why that makes so much sense. Because whereas right here we traded 2 tacos for 1 hamburger, and then as we move from Q to R, we trade 1 taco for 1 hamburger. Well, that means that these marginal utilities must be adjusting as well, because those two have to equal each other. So just kind of keep in mind that as we're dealing with these indifference curves, these ISO utility curves, that as we move down that indifference curve, the marginal rate of substitution falls. And then as we move down this indifference curve, we're going to be willing to give up, in this example, less tacos for 1 more hamburger as we move down this indifference curve. And the very simplistic reason why is because of the law of diminishing marginal utility. Because as our taco consumption falls, we place more value on those tacos. And as our hamburger consumption rises, we place less value. So we're willing to give up less tacos for the same amount of hamburgers because, well, our utility is higher on those tacos the less we consume.